In this video what I want to do is show you how to use reflection mapping to save yourself some render time when using true ambient rendering. I'm going to set the scene up with true ambience, and I'm going to use a HDRI that's provided with one of Horo's and my products. It's a HDRI made by Horo and it's called Garage Closed. I'm only going to use the medium resolution version because I only really need it for reflections. So there it is. I'm going to reduce the quality and turn the intensity up, turn the specularity to 0, turn the HDRI effect to 0, and make sure it's added to the sky. I'm going to check out of here now. Note before I do that the sunlight's been automatically disabled, and what I'm just going to do is turn the atmosphere off and set it to fully black, and then give it a render in regular mode just to show you that the only thing that you can see at the moment is this perfectly reflecting sphere, and that's because it's reflecting the HDRI backdrop that's added to the fully black sky. Now at this point, if I switch over in render options to premium effects and go true ambience, I'm going to leave it at 64 rays per pixel and leave the maximum ray depth at 6. And I'm just going to make sure I've got true ambient scattering corrections set and boost light set, and give this a quick render. Okay, it's quite noisy, and this noise is coming from the image of the HDRI backdrop, but it's providing a bit of light, but the light it's providing is, as I say, quite noisy. It's also coloured. It's not an ideal situation. We're looking at a render time of about 2.5 minutes. Now if I go back into the render options here, I can show you that if I change the maximum ray depth down to 4 for example and give it a render, we'll see whether that saves us very much render time. Okay, it's saved us a bit and the effect is more or less the same, so you can see that that's worth doing, but I want to optimize this a bit further and I want to reduce the amount of noise. So what I'm going to do is I'm going to create a gel light. So I'm going to create an ordinary radial light. I'm going to edit it, turn off the diffuse, the specular, turn on transience optimization, use gel, and in the procedural I'm going to set it to default grey and then turn the ambience up. In fact, I don't need any diffusion. So there you go, that's my light object now. And check out of here, change the family groups to indicate that it's a different sort of light source, and then enlarge it so it's wrapped around the entire scene. And since it's got ambient, I'm going to give it a bit more ambient from the global ambient and see how much light that provides. So you can see it's provided a little bit more light, not very much, than the background was providing at the setting. The light source, even though I'd set it to default grey and then turn the ambient up and then turn the diffuse off, it isn't interfering with the reflection, which is a bonus. It's not quite providing enough light for what I want. The render time's about the same as it was before. So I need more light out of this, so I can do that by using a hypertexture. If we go into the material now and click on this channel A for the ambient, and then hold the shift key down and go to the basic, and just as in the previous videos with the hypertextures, I'll start with check blue, go into the deep texture editor, just turn off color and bump output and work on the alpha. Open the noise dialog, and in where it says square there, go to distance squared, mode minimum, octaves 1, and well, actually I don't think it really matters with the frequency. I've been setting it to -1, but I'll just leave it the same. In fact, I'll turn it down to a 2D and see what happens. So it's by way of a bit of experiment. These stripes indicate it's an out of range value, and so that's given me a highly negative output. You see, ambient would normally white ambient with that kind of setting. So I'll just make sure I've got alpha scaling set, so that'll give me some kind of control over this, and what I'm looking for is to have a positive output. So if I drag this component into the second component here and use difference, which is there in the blend mode, and then go into the noise for this second component and just set it to nothing, I don't need 2 octaves now, I can turn that to 0, then the difference between this highly negative value and nothing will be a highly positive value. So now I've got enormous output from my hypertexture here. However, probably a bit too much output, so I'm going to modify this still further by taking this second component and dragging it into third using multiply, and then I'll filter this with a sine function, reset it, and as before, by lowering the values here and watching these stripes, I want them to spread out but not go fully black, and that will indicate that I've brought it down into a usable range. So it's a bit fiddly, Right, that's probably usable. So the stripe's starting to spread out. I'll see if I can get it a bit further. This might be where the frequency modification here might help. I'll just try that now and see if this is going to help here. Yeah. So the lower the frequency here, the lower the value is becoming. That's worth knowing that. So I'll fine tune it so it's not vanishing. I can go down to 1 or -1. I'll go back to -1 because I know where I was with that. Okay, so this will be a positive output, higher than the normal range of 100, but it'll be in a useful range now. So we went from highly negative to highly positive to scaled down to be usable. So at this point I should be able to wind this in, see, so we're in the normal sort of range. So I'm going to have to guess at an output here that's going to be suitable and then modify it bit by bit. So I'll try ambient 5. Okay, let's see, have we got a lot of light now? Not bad actually, pretty lucky guess there, possibly a bit too much. So I'm going to modify this a little bit further. I'll go for 2 and see if that's brought it into a more of a grey range. That's too low. So a bit of fine tuning here and then we'll be ready for the next step. So we'll try 4. Okay, so nothing's absolutely fully white, which is what I was aiming for. You can see though we've got a fair degree of contrast because I want to add at this point some reflection onto this material so I can take advantage of this HDRI image in the backdrop. Okay, so render time is about 2.5 minutes. I'm going to modify the materials on the objects, so here we go, and all I'm going to do now is put in, say, 10 reflection on there and watch what happens to the render time now. So I've put in 10 reflection and the render time has doubled effectively, possibly a bit more now. It's had a chance to rethink about how long it's going to take. It's getting on towards tripled. And that's just to have these reflective highlights. So what I want to do is get the same kind of effect but without the overhead in render time. I'm going to use reflection mapping to achieve that. And what I'm going to do is I'm going to export the HDRI image as a spherical map. So in the image based lighting tab I'm going to set this down so that, let's see, I'm going to set it down to 1. So you can see now that everything's dark in here except for where the lamps are, and I'm going to export this image and I'll call this exported spherical map 1, and I'll choose spherical in this final option. That's important there, and just save that. Right, in order for the mapping to work with the reflection mapping, what I need to do is flip this image around and offset it. So I'm going to use Paint Shop Pro for that, and I've done this a few times before just to double check that I did know what I was talking about. So what I'm going to do is bring in that image that I've just exported and then go Image, Mirror, and then Effects, Image Effects, Offset. What I'll do is set the offset to the center and then just change the vertical offset to 0. So what that's done essentially is move the whole image along 180 degrees. So File, Save Copy As, I'll just save that as a JPEG. Right, don't use too much compression when using the JPEGs. Go back, utilize this hypertexture material here. So I can just save this in one of my libraries if I can find somewhere to save it. Let's see, here we go. So I'll call this pos ht low. Okay, check out of that, check out of that, and then I'll go on to my material, and in the ambient output here, oh, it's dropped it straight in. That was lucky, wasn't it? It found it from the library, otherwise we're going to have to pick it out. There you go. But it found it. So that's now going to give me a high ambient output. And then for the ambient color from the picture channel, I'm going to select my modified image so that's been mirrored and offset. So check out of that, and then I'm going to set the ambient level so I get some nice bright highlights. So the last thing I need to do to get this to work right on the model is set this to a reflection map. Right, and then check out of here and then give that a render. Okay, so the last thing I forgot to do was turn the reflection off. So we've just got, so not just not just the ambient, giving the illusion of reflection. So there's reflection value set to 0 now. So it was about 7 minutes 55, something like that, and now we're bound to 3 minutes 22, so 3 minutes 12. So you can see this is about half the render time. And I suppose just to set things back up and show you, I'll set this up to, what was it, 10, and then I'll get this sphere and drag it across into the middle here, modify the material so I've got 10 reflection, turn the ambient off there, so we've got a comparison. So that one is using reflection, this one's using fake reflection. So if I can get them balanced out about right, you should be able to see that using the reflection mapping and a spherical map of the background is a reasonable simulation of the reflective effect. It's not perfect, but if you've got a fairly complex model like this, then it would be difficult for the person viewing it to know exactly what the distribution of reflections should be on that model, and which bits of the model could see the background and which couldn't. Like it's probably this one would give the game away because it wouldn't be able to see the outside. So is a refinement to be made here that still won't cost too much render time? Now that's the difficulty, to know the answer to that. See, if this image could be now bound into the diffusion, then the amount of reflection, whether it received light, would determine whether it was lit up. But at that point, then you might run into other issues. So maybe it could be bound into the specular channel, but then you would have to provide specular lighting from the outside, and then you'd have shadow rays, and that would tend to increase the render time. So any other method that you might use to further refine this has the potential to increase the render time. So it's not a foolproof method, it's just an alternative way of achieving this effect, and it will very much depend on the type of scene that you're going to use it in. But it's worth knowing about these things, because what I plan to do is I've been experimenting again with subsurface scattering, and the last thing you really want to be doing if you're using like blurry transmissions is also having reflections thrown in, but you do want reflective highlights on plastic material. So this was a way of achieving that effect without having the penalty of getting reflections interacting with transmissions. But I thought I would start off with this because it explains the technique without me getting too bogged down in starting to discuss the subsurface scattering effects and how you can simulate that. So you can see it's almost rendered out. And I think what I'll do is I'll render this out at the maximum rays per pixel so it's not so noisy, and then use that for the image that starts the video. Okay then, so I hope that's proved interesting and that you'll experiment with this effect in your own renders. That's the end of the video.